Hello there guys, welcome back to another epic Inexorable maths video. In this video, we're looking at proof by exhaustion. So proof by exhaustion is, to be honest, is probably the easiest method of proof, I would say, in my opinion. It's basically the type of proof method that most people will just use when they don't know how to do a proof. So it's called proof by exhaustion because what you do is you literally exhaustively go through every single case, show that it's just true by brute forcing it, basically. So let's just do an example and you'll get what I mean. So here's a question. Prove that when n is an integer and between 1 and 6, including 1 and including 6, then m, which is n plus 2, is not divisible by 10. So m, which is this n plus 2 number, it's not divisible by 10 for n is an integer between 1 and 6. So how do you prove it? You just go through every single 1 to 6, just show that none of them are divisible by 10. It's very simple. So let's go for it. So let's start with the first example here. M, which is n plus 2. So the first value for m is, well, we're starting on n is 1. So it's 1 plus 2, which is 3. Is 3 divisible by 10? I don't think it is. So that's not divisible by 10. Okay. Well, when n is 2, we do 2 plus 2, which is 4. Well, that's not divisible by 10. When m is 3, 3 plus 2 is 5. That's not divisible by 10 either. And we just keep going. So what's the next one? We've done 3. So 4 plus 2 is 6. Not divisible by 10. It's just going up because it's a constant thing. So it's 7 is the next one. And finally, when n is actually equal to 6, 6 plus 2 is 8. Well, we can see here, none of them are divisible by 10. So we've done the proof. It's really that simple. Let's do another one. So we want to prove that for all prime numbers p, where p is between 3 and 20, p squared is 1 greater than a multiple of 24. And again, this is one that you can easily do by exhaustion. We'll just go through every prime number between 3 and 20, square it, and see if it is 1 greater than a multiple of 24. That's the plan. I've equipped it with my calculator because you don't want to get your mental maths wrong, guys. And in the exam, you're allowed a calculator, so you might as well just use it. All right, here we go. So we're not including 3, because 3 is a prime number, but we're not including it because it's not actually included in the inequality sign. So the first number is 4. 4 is not a prime number. We don't count it. 5 is the first prime number that we actually want. So let's try when p equals 5. Let's see what happens when we do that. Well, if we square 5, we get 25. So p squared is obviously 25. Now it's pretty clear to see, is this 1 greater than a multiple of 24? Well, yes, of course it is, because 1 times 24 is 24, plus 1 there's 5. So it's 1 greater than a multiple of 24. Lovely, so it works. We're happy with that. Yes, amazing. Okay, next prime number, not 6, it's going to be 7. So 7 squared. P squared is 49, and that's 7 squared. Well, 2 times 24 is 48. 49 is 1 greater than 48. Statement holds. All right, next prime number, not 8, not 9, not 10, it's going to be 11. Okay, p squared is going to be 121. Right, 24, let's do this. 24 times, oh, I think it's 5, right? Yeah, 24 times 5 is 120. So you could write this, 24 times 5 is 120. 121, it's 1 greater, so it holds. Lovely. Next prime number is going to be 13. 13 squared is 169. Okay, and I'm assuming 168 is divisible by 24. Yes, it is. It's 7 times 24. So you can say that 169 is just 7 times 24 plus 1. Amazing. Right, next one. 14 is not, 15 is not, 16 is not. It's going to be 17, guys. 17 squared is 289. Okay, So 288, if we divide that by 24, yes, it's 12. Of course it is. So 289 is equal to 12 times 24 plus 1. So it's 1 greater than a multiple of 24. All right, next prime number, and also the last one is 19. 19, and I don't know what 19 squared is. I cannot remember for the life of me, guys. It's 361. So 360 divided by 24 is 15. So that means that we have got that 361 is equal to 15 times 24 plus 1. So I would set out the answer to the question like this, and you can give them little ticks if you want. You can feel like the examiner. But I would set it out like this because it really shows that each number is 1 greater than a multiple of 24, where we've got prime numbers here. That's basically it, guys. That's really all it is. In general, in the exam, when they ask you a question about proof by exhaustion, you might say, really, is this it? Is this all it is? They will typically give you a proof by exhaustion question. It will not be many marks at all. It will be 1, 2, maybe 3 marks. And then they'll ask you a follow-up question involving an actual kind of proper proofy proof that may be related or unrelated to the proof by exhaustion. It's quite rare that they would just ask you a proof by exhaustion question on its own. They can do it. It won't be many marks though, so just be warned. That's basically how you do it, guys. Hope you found that helpful, and I'll see you in the next video.